And the last method I want to take a look at for systems of equations is the elimination method. So I'm going to start it very similar to how I started the addition method. So I'm going to rewrite the second equation underneath the first equation. Okay. Now the issue that we're going to run into is if you look at the x's, they're totally different. Multiplying by -1 isn't good enough. If you look at the y's, same thing. Multiplying by -1 isn't good enough to get rid of the y's. And I can choose to get rid of x or y, doesn't matter. And actually, I'm going to go ahead and erase the second equation over here because I'm going to need some space. So I have to choose. Do I eliminate x or do I eliminate y? Again, it doesn't matter which one you choose. I'm going to choose the one that has smaller numbers. So I'm going to go with the x's. And we're going to go and try to find the least common multiple of those two coefficients. So in this case, I have a 2 and a 3. The least common multiple of 2 and 3 is 6. The smallest number that can be divided by 2 and 3. Now, if you pick a multiple that's bigger than the least common multiple, that's okay. You're just going to deal with bigger numbers the whole way through your problem. Now, I want to be able to use the addition method. So I'm going to try to get to 6 before both x's. But not only do I have to get to 6, but I have to get to positive 6 and negative 6. So in this first one, I'm going to multiply by 3. That's going to get me to a positive 6x. So I'm going to multiply the entire problem by 3. So I get 6x plus 18y is equal to positive 12. Now the second one, since I have a positive 6, now I need a negative 6. Just like the addition problems, they have to be opposites. So I'm going to multiply this one by negative 2. So again, the entire problem by negative 2. So that gives me negative 6x plus 14y is equal to negative 12. Now if you look in my new problem, now I have inverses at the x's. So if I add them together, they cancel out. And I add up 18 plus 14, and that gives me 32. Y is equal to 0. Divide both sides by 32, I get y is equal to 0. So my ordered pair is something 0. So just like the substitution problems, just like the addition problems, now I have to go back and solve for x. So I'm going to take the equation that looks easier to me, so I'm just going to use 2x plus 6y is equal to 4. And I'm going to substitute the 0 in for y. So 2x plus 6 times 0 equals 4. And I'm going to solve for x. 6 times 0 is 0, so 2x is equal to 4. Divide both sides by 2, so x is equal to positive 2. So my ordered pair is 2, 0. So the intersection point of those two lines is 2, 0.